Thank you everyone for joining our webinar today. This is Dynamo 101 for MEP Contractors. This session is led by Evolve Product Manager and resident BIM expert, Jason Earl. We will be having a Q&A at the end of today's presentation. So please, as we're going along, use the Zoom Q&A feature to submit your questions, and then we'll get to them at the end. If we don't have time to get to your question, we will make sure to follow up with you by email. This webinar is being recorded, and the recording will be forwarded to all registrants. You can also find all of the Evolve webinar recordings on our YouTube channel, so make sure you are following us over there. So with that, I'm going to hand things over to you, Jason.
Great, thanks, Marina. So this is going to be Dynamo 101, a couple housekeeping items, a little bit about the agenda. We're going to go through a few slides here to go over what Dynamo is. Then we'll go over some basic concepts, followed by building a Dynamo script. And then if you have any questions, we will do a Q&A session towards the end. So hold those questions to the end. And so let's dive into it. So this is Dynamo 101. All right. So what is Dynamo? Most of you may or may not be familiar with Dynamo. Some of you may have used it a little bit. Some of you may have heard about it. But what exactly is it, and what can you do with it? So first up, and mainly, it is a visual programming environment. So there's no code required. You can write code in it, but it is not required. It's built in blocks. So you'll build your script or your graph by connecting blocks together, and those blocks will do something to the input and give you an output. Dynamo is really, really good for task automation, especially repetitive tasks, and can help you save a lot of time. For parametric design, Dynamo is very, very good for manipulating parameters, reading parameters, taking those as inputs, and then driving parameter outputs as well. Custom workflows, you can more or less do anything in Dynamo that you can do in Revit. You can actually do even more in Dynamo than you can do in Revit. So anything that you're doing that's repetitive, you could, in theory, create a Dynamo script for it. Within Dynamo, you'll build your graph, you'll test it, and you'll execute it all from Dynamo. Data analysis is another area that Dynamo excels at. You can extract data from your model. You can run calculations on it. You can even visualize data within Dynamo, especially geometry, and perform analysis. You can also import and export data with the help of a few nodes. An extension. So Dynamo has a very vibrant and active community that creates custom nodes. So Dynamo has a set of nodes or blocks that come out of the box, but there are a lot of community built packages to extend the functionality of Dynamo. All right, so why would I use Dynamo? These are kind of some of the highlights. So you don't need to be a developer. I'm not a developer. I'm not a programmer. However, I've gotten a lot of use out of Dynamo. You can build what you want when you want. So you don't have to wait on a developer to build something for you. You don't have to hire a developer. And if you're using software, you don't have to wait for an update. An active and helpful community. So there's a very active forum for Dynamo. Google, there's a lot of search results when you look up things for Dynamo. And so it's a great way to get additional resources. Something I mentioned earlier, there's a lot of community-made custom node packages. And then last but not least, Dynamo is free. So it's a very, very low barrier to entry with Dynamo. Next up, so what you might be thinking is, how can I learn Dynamo? You can learn a little bit here today. We're going to go over some very kind of basic concepts, and we're going to build a pretty basic script, but hopefully one that could still be useful for you all. So some of the places where you can learn things. The official Dynamo website is dynamobim.org. So that's one place you can go. From that website, you can find the Dynamo primer. This is kind of the getting started guide for Dynamo. They also have tons and tons of tutorials on that website. The forum.dynamobim.com, that is the main forum or the official forum for Dynamo. So there's a lot of questions going back years and years and a lot of really helpful answers. YouTube is also a great place to learn, or anywhere else you might find content. One that I've listed here, somebody that I learned a lot from is Aussie BIM Guru. He puts out videos, I think, weekly, and a lot of them are really, really great if you're trying to dive in depth on those topics. And the last one and the most important one is to start building. So if you want to learn Dynamo, at the end of the day, what you really need to do is open up Dynamo and start trying to build what you want to build. And Google will definitely be your friend doing that. All right, so let's get building. So we're going to jump into Dynamo now, and we're going to go over a couple basic concepts. And once we finish doing that, we will start building a Dynamo script. All right, so I've got Dynamo over here already opened, but in case you're not sure how to get to it, let's open it again. So when you're inside Revit, it doesn't matter what year you're in, I think as long as you're past 2018. You're going to go up to the Manage tab, and then you're going to hit Dynamo. Now you'll notice up here, the button group here is called Visual Programming. There's two buttons. There's Dynamo, and then there's Dynamo Player. Dynamo is what you'll use to create your scripts. The Dynamo Player is used to execute them. However, depending on the graph you made, you may just always run it from Dynamo, and we'll look at that right now. So when you open this, it's going to open another window, and you're going to get the option to start a new Dynamo graph. There's some other buttons, but right now we're going to jump into one that I have already built. We're going to go over that. All right, so this is kind of your environment where you'll be building everything. If we look over here on the left, we've got our library. So these are all our nodes that we can use to build with. So if we look in here, these will expand and you can find your nodes. You can also search in the search bar. It works pretty well if you know the name of the node. Some of them are named a little odd, so kind of learning what to type in here comes over time to help you find the right nodes. You'll also notice down here, add-ons. So those community-made packages that I talked about earlier. Right here, I've got a few of them already installed. And one that we'll actually be using extensively today to build our sample script is going to be this Dyna MEP. So these add-ons, how do we get these? Where do we go? So if you look up in the top, the menus up here, there's one called Packages. This is how you're going to get those community-built packages of nodes. So in here, we can search for a package. And then that'll bring up the package manager here in a second. And once that opens, we'll see you can search through the packages. You can sort them by the most downloads, and then you can also select which program that you're using. So what I recommend whenever you're looking for packages, go up to filter by, and once this finishes syncing, you'll see a host of different Autodesk programs. Revit is the one you'll want to select. And then I typically suggest sorting by downloads here. So that's typically what you'll want. For some reason, the server is not sending me any packages, but we could reopen that and it would show those. Now, do note when you install those packages, many of them do utilize Python. Python is a programming language. You can actually write Python within Dynamo. That's kind of one of the more advanced concepts, but just something to be aware of. Those do install executable code. All right, so let's kind of jump into what I've got here and let's talk about these. So these are nodes, and what you see me clicking here are what I call wires, but that's how you connect the nodes together. So I've got here a very, very simple set of nodes here. This node here is for addition. And where I got that, I just typed in plus in my library, and it comes up with this node. So if I wanted to add this node, I could click on the node there and it would bring it into the space. At that point, I can move it around and place it wherever I need to. So I've got this one here. I've got a node for a number. And so I use the number 5. And what we're going to do is we're going to add 5 and 5 together, and we're going to look at the result. To connect these things together, if you'll notice, each node has a set of buttons on the left and on the right. On the left, you have your inputs, and then on the right, you have your output. And then the node itself will do some manipulation of the input to help to get you to that output. So I'm going to take this number here of 5, and I'm going to connect this over to the X, and I'm going to connect it over to the Y. If you hover over the node, you'll see a box usually pops up above it. That will give you some description of what the node does, and it will also tell you what type of input it is expecting typically. So if I hover over the X here, so that is telling me that my input needs to be an integer value, double value, or string. So data object types is going to be a key concept when working in Dynamo. Your inputs must be compatible with a node. It must be a compatible object type that that node is expecting. So now that we've got those connected up, I'm going to go ahead and hit run. Let's connect this one as well. So when you're working within the Dynamo environment, the way you'll execute your scripts is by hitting run. And so you'll be doing this a lot when you're building your script and testing it. One thing to note, when you first open Dynamo, this menu down here is going to say automatic. That is going to run the graph whenever you change it. I always switch mine over to manual. So at this point, let's hit run. And it lets us know down here that run completed. And I've got this node over here that just shows the output of this plus block. So I can see here, the output was 10, which is what we would expect. 5 and 5 is 10. One other thing we can look at here with these nodes is if I hover over a node, typically a list will pop up down here. I can hit this little pin icon so I can see the output of my node as I'm working along. So this gets very useful when working in larger graphs. All right, so now that we've got the idea of a node down and connecting our nodes together, let's start to look at something a little more complex. So down here, I've got a graph or a set of nodes here. And what these nodes are doing is I'm searching for even numbers. So what I've got here on the left, I've got this code block. So there's a concept of design script that we won't really go into too deep. However, on the Dynamo BIM website, they've got all tutorials and documentation about design script. Design script is a way that we can write little snippets of code that will help our graphs. So over here on the left, what I've got going on is I've got this line here that is giving me the numbers 1 through 10. And then over here, I've got the number 2. Next up, I'm taking the inputs from here, and I'm taking them over to this modulus node. Modulus, all it does is it divides X by Y, and then it tells you what the remainder is. So if the remainder is 0, then we'll know that that number is even since we're dividing our numbers by 2. So I've got my input to the modulus node, and we can actually look at what the result was. So I took this list of 1 through 10, and I divided it by 2, and this node tells me what's the remainder of that. So we can see for some of the numbers, the remainder was 1, and for some numbers, the remainder was 0. Next up, I'm taking this list of 1s and 0s, and then I'm asking it a question, essentially through this node. I'm saying, is X equal to Y? And I want to know if it's equal to 0. And the result of that is a data type that we call Booleans. Boolean is either true or false. So very, very basic concept there. So I see that the 1 over here came out as false. 1 does not equal 0. That's what we expect. Awesome. And so that just goes through the list there. And as we see down here in this little output, we can see that we're working with lists. Lists are another pretty important topic in Dynamo. You'll be doing a lot with lists. Essentially, every output and input will be a list. Sometimes you can have just one item or one element or one object that won't be in a list, but generally speaking, we're working in lists. Those lists have levels. So if we look over here on the left, we've got a list that contains a list, and that list contains a bunch of objects. And so we're not going to dive too deep into list management in this webinar. However, you'll be learning more about working with those lists and making sure that your lists have the appropriate level nesting. On the nodes themselves, a couple of the buttons that we didn't talk about, these ones over here, that actually deals with your lists. And there's an option to use levels. If you turn that on, you'll start to see this over here, and you can change the level of the list that's being taken as an input. So I won't go too much further into that other than to show you it's there. But learning to work with lists will become an ever increasingly important concept as you start to build more and more complicated graphs. So once I've done my equals test to test if my numbers over here are equal to 0, I've got this other node over here, this list.filter by bool mask. So the reason that I included this in the basic concepts is because this is how you're going to filter inputs. So this would be how you would filter elements, whatever it may be. So a common concept in Dynamo is you're going to have an input of some elements, typically from your model. So whether that be a view, a set of selected elements, all elements of a category, all elements where they have a certain parameter, whatever it may be, we're typically going to have an input that contains more than what we want. And we want to look at those elements, and we want to see which ones answer our question. So we want to know, does this parameter contain this value? Is this object intersecting with another object? Whatever it may be, typically we're going to have some set of input. We're going to ask it a question about itself, and then we're going to filter the original list by the result of that question. So if that question is a set of true or false, so you ask an element, do you have this property or do you not have this property? Very, very common thing that we'll be doing with Dynamo. So what this node over here is doing, this list.filter by bool mask, the mask is actually a set of trues and falses, a list of Booleans, as it says there. So over here on the left, we've got our list of Booleans. And then a little farther left, we've got our input list here. And I'm just going to show that list again to reiterate my next point. So if you'll notice here, if we look at these two, these lists match each other. So whenever you use a list.filter by bool mask, you'll need to make sure that the amount of items in your list right here matches the number of items in your mask, your set of Booleans. As long as those match, the node here, the filter by bool mask, is going to look at each one. So it's going to look at the 0 indexed object. So 1 is false, and then it's going to filter that out. So what do we get from our filter? We can see here on the node on the right side, which is our output, we've got in and we've got out. So if we look over here in the watch, what was in, and that would be which ones were true, we can see that those are all our even numbers, 2, 4, 6, 8, 10. And then on the out node, I'll run this again. And now we've got that. So we can see now we've got all our odd numbers. So pretty straightforward concept here, but if you've never worked in Dynamo, accomplishing this can be a little complicated. But important thing is to remember, when we want to ask a question about a set of elements and we want to filter them by the answer to that question, we'll use a list.filter by bool mask. A couple other things that I'm going to talk about real quick. We'll skip that one for now. So object.type and string from object. Remember when I said earlier that the nodes must have the object type that that input is expecting. If they don't, you'll get an error. So if you're kind of pulling your hair out wondering why this isn't working together, you say to yourself, I really think these are compatible. This should be working. Why is it not working? What we can do is we can take the output of a node and we can bring it over to object.type. This node will tell us what type that object is. So if we hit run here, we see it tells me system.boolean. So I know now that all of these are Booleans. There are a lot more object types. There's all kinds of ones you've probably never heard of, but certain packages of nodes work with different objects. And so you'll just want to make sure they're compatible. And this is a great way to check it if you run into any issues. One other node that I wanted to bring up is called string from object. So something you'll run into pretty commonly is you'll have a set of elements and you might be interested in the name of that element, or some output that is not a string. So a string being a set of numbers and letters, essentially a word. So you can always take any output. So these are Booleans. I can take this and I can convert it to a string. So when I get that out, it looks the same. But if we check the object type, we can see now that those objects are strings. So another useful node there to be aware of. One last thing that I want to cover here in the basics is going to be a common design script function. And that is right here. So in this code block, what I've got here, it probably looks like a foreign language. It still does to me. But what this is doing is it's asking a question. So this is actually an if statement. It's saying if x modulus 2 is equal to 0, and then that's indicating our question part of the statement. And then we have what happens when it's true and what happens when it's false. So what should the output be if x mod 2 is equal to 0? And then what should the output be if x mod 2 is not equal to 0? This code block right here can actually replace these three nodes right here. So as you start to get better at design scripts, or if you just learn this one, you can ask questions about your inputs a little bit quicker and easier. So if we connect those together, we've made our graph now a lot smaller, a lot more compact, a little bit cleaner. All right. And so this is something that you'll run into when your objects are not compatible. So if we notice here, this warning's not super helpful. I'm not entirely 100% sure what it means, but what's going on here is my code block. I've got the output being a string. So this is saying in quotes, it's a string and it's true and false. If we remember from earlier, this mask is expecting a set of Booleans. So we can actually change that in here to Booleans. Then we can run that, and now we see that it works. So again, important concept there of making sure your inputs match the expected object type. And then this node right here is a pretty commonly used statement. All right, so now that we've got that, that's it for the kind of basic concepts. So let's start jumping into building out a little bit more useful script that actually does something. So I'm going to close this. And I'm going to open up this script right here. Now, before I get started on this, let's take a look at the model that I have open. If we go to a 3D view really quick, we can see I've got something here that many of you might be familiar with this scenario. This might be a little more familiar for the electricians, but for mechanical, the same concept also applies. So what I've got going on here is I've got some conduits, or you could think of some pipes that are running under a floor, and then they turn up and they stub up above that floor. Now, when I go to install this in the field, I'm going to need to know where I need to drill a hole in the slab. So what we want to do here is we want to place a point on the end of this conduit so that I know where to drill my core. So that's what we're going to do with our script. We're going to select an end here that we want, and we're going to have Dynamo automatically place a point on the end of that. So this can be very useful for stub ups, or any case where you might have an open end of a pipe, a piece of duct, a piece of conduit, whatever it may be. What this script is going to do, it's going to look at this connector. So that's kind of the key requirement for this script, is something that has a connector on the end of it. All right, so jumping back into Dynamo, we're going to walk through this script, and I'm going to kind of rebuild it as we talk through it and what each node does. So we'll take these off, and we'll just start walking through each set here. All right, so this first node that I have here is select model element. What this node allows me to do is, if I hit change, we'll notice kind of in the background, Revit changed a little bit. So we see everything's grayed out. And if we actually look in the bottom left here, it's telling me to select a model element. So that's what this node does. So I'm going to select one of these conduits here. And I'm done with that. So let's go back into Dynamo. So we can see here that I've got this element. That number you're seeing is called the element ID. Every element in Revit has an ID. That's how Revit keeps track of everything. And it can be very useful. Next up, we've got this element.connectors node. But let me back up 1 second. So where did I get this node? This is one of the out-of-the-box nodes. If I go to select, if I search that, if I go over here to selection, Dynamo has out of the box a pretty wide set of nodes for selecting different types of elements. This one requires me to have Dynamo open. I actually can't run this script through the Dynamo player. This one will only be run through the Dynamo environment. Now, you can create a node using Python. There may also be a package out there for it. I'm not aware if there is. But you can create other selection methods that will allow you to select multiple elements. You can make it filter what you can actually select. You can do all kinds of things. But that one is going to be using Python. So before I keep going, we're not going to be building any Python in this webinar today. But one thing I will point out is, if you want to use Python, you can just type in Python, and you'll find this Python script, and you'll get this node here. And if you double click on the node, it will open up our Python script editor. So this is how you would use Python. And then there's great resources on the Dynamo BIM website for getting started with Python. All right, so moving on, Next up here, we've got elements.connectors. And where I got that from is from this Dyna MEP package. So out of the box, Dynamo doesn't have very many nodes for working with MEP elements. But most of you here today probably work on MEP projects. So these nodes are going to be extremely, extremely helpful. So this node that I've got here is taking an element as an input, and it's getting the connectors. So let's connect those together, hit run. And now we can see here, I've got this conduit element, and it's bringing it into my element.connectors. And we can see the output of this node. It let me know that there are 2 connectors. So that's great. So I know that this element has 2 connectors, one there, one there. And I've got those connectors, that's great. But what I'm interested in, what the question that I need to ask Revit with my Dynamo script is, which end is not connected to anything? Because remember, really, I want my point up here. I don't really want my point down here. And I certainly don't want 2 points. In an ideal world, I might actually want my point to rest on the top of the slab here, or the floor. And that is possible, but it's a little bit more complex, and we're not going to do that today. But it involves kind of getting the geometry and checking where that line intersects this top plane of the floor. So we won't do that today. For today, having the point on the connector is going to be good enough. So let's look at what nodes we'll use to ask these connectors, which one has nothing connected to it. So the way that I'm going to do that is I'm going to use this node here, connectors.isConnected. So I'm going to take my connectors, the output of this node, and I'm going to make that the input of my isConnected node. So over here, I've got that run. And so now I can see I got some Booleans. So remember, we talked about Booleans earlier with the bool mask. We're going to be using that again here in this one. So I've got false and true. So now I know that this second connector here is the one that is connected. And the first one, or the 0 index, is not connected to anything. So now I want to do something with this connector. I need to get the location of where it's at, right? I'm placing a point, so I need a location to place that point. So the first thing we're going to do is we're going to filter this list of connectors, bring those together, hit run again. We can see in our output, my in list, that is true. So those are the ones that are connected. But what I'm interested in here is this out list, the ones that are not connected. So now I'm going to take the out output, and I'm not going to use the in one. I don't care about the ones that are connected. So I'm going to take the out, and I'm going to connect it to our next node, connectors.location. So this node is going to give me the location of that connector. I hit run. You can actually even see there in the background, we got some geometry. So I'll mention that here in a second. So if we look, this node's letting us know that the output is a point, and I've got these coordinates here for a point. So I've got 3 axes here, so it lets me know where that point is in X, Y, and Z space, according to, I believe it's the Revit internal origin. There's a lot of different coordinate systems in Revit, but I believe this is the internal origin. So let's talk about this little point that appeared in the background. So one of the really cool things that we can do in Dynamo that maybe is sometimes applicable in MEP, but is most often used kind of in architecture, and that's working with geometry. So if we look up here in the top right, with this button over here, this is graph view, but I've also got a 3D view. So this is kind of the geometry view. So if we switch to that, our nodes turn gray, and we can see the geometry that we're working with. So you can actually get the geometry of elements and work with those. All right, coming to our graph here, I've got the location of my node, but I need a little bit more information before I can place a point. So the node that I'm going to use to place that point is the family instance.byPoint. And so this node Let's look that up. If we look here, so these are nodes that come out of the box with Dynamo, and these are nodes for either modifying or placing a family instance. If we look in Revit real quick, so what is a family instance, or what is it exactly? Well, if we look on the left here in our families, these are our categories. We'll do generic models because that's what we're going to be using. So generic models is a category. This EV point, that's the family we'll be placing today. That is a family. And if we expand that, we've got a list of family types. So none of these are family instances. When I go and I actually take a family type and I place it in the model, I'm creating a family instance. So that's what a family instance is. So everything you see on the model is a family instance. All right, so coming back into our graph, I've got my location of where I want to place my family instance. So I've got the point here. So we've gotten the location. However, I need one other thing. Revit needs to know what family type I want to use. So how do we access this? I believe we're using the layout point. It'll be the first one. So how do we access that type? Let's take a look at that. So the first thing that I'm going to do is I need to get the family. So there's a pretty good set of nodes for doing that. This one is called family.byname. This is another out of the box node. So what I can do here is I've created a code block that I've typed in a string, and we know it's a string because it's got quotes around it. And that's going to be my input for this node here. So this is the name of the family. Hit that. Let's freeze that. We don't want that to run. All right, so I'm going to hit run. All right, so it found that family. So this family is an object in the Revit project, and we've got it here. It even has an element ID. All right, so what we need is a type, though. We don't need the family. So next, I'm going to get the types of the family. So family.types. So I've got the output of a family. My next node is expecting the input of a family, and it's going to give me an object type of family type. So we'll hit run again. Pin that. So we can see here now we got a list of family types. I've got their element IDs. And so now we need to get only one of these. For the purposes of this webinar, which one we get isn't important. But when you're creating your own scripts, you may want to ask a question about this list and say which one contains the word layout point. That's a way you can filter your list to get the type that you're wanting. So again, filtering your lists using a Bool mask, very, very common thing that you'll be doing. All right, so let's bring this over here. So I want to get one item from this list. There's a lot of different ways to do that. What I've got here is just something basic, list.first item. It's going to give me the first item from this list. So let's run that. And look at that. So now we've got a single family type. So at this point, we're all ready to start placing points. That's, for the most part, that's the entire script. There's a lot of different enhancements you can make to this script in terms of choosing which type you want. You could beef up the selection method to select multiple elements. That would take more or less rewriting this whole script to deal with multiple elements, but you could certainly do it to place points on all three of these at once. So I'm going to unfreeze this one. And so when you're working in Dynamo and you're testing and building your script, sometimes you don't want certain parts of it to run because you're messing with something else, and it might add families to the project or do something that you don't want to deal with undoing. So you can freeze a node, and when you run it, that node will not run. So I'm going to unfreeze it here. And I'm going to hit run. So if we look, this node's telling me that I've got a point. So let's check in our project and see if we actually got a point. And look at that. We have a point placed on top of this conduit here. So let's try that again. Let's see how this works. All right, so I'm gonna change my element. I'm gonna place it over here. Then I'm gonna hit run again. And just like that, I've got a point there. So this is an example of how you can create a script to place a point in your family. Now, one thing to keep in mind, when you do work in the environment like this, when you run your script, it's essentially going to undo what you did before. So you notice I don't have a point here anymore and it placed it there. That's something that will happen. So if you're using this one, you'd have to kind of close out of it and reopen it. Really what you want to do, and what I encourage and challenge everybody here today to do, if you think this script might be useful for you, start learning some more about Dynamo and go try to find how you would select multiple elements from being prompted. So that's an enhancement that you could make to the script to make it a lot more useful. All right, so that is our Dynamo script. And we will be following up with the slide decks from today. So we've got another one coming up. We're going to talk about some of the things to be aware of when using Dynamo, some of the drawbacks, but some of the pros as well. But we will be following up. You'll get the slide decks that we used today and the 2 scripts that I went through. So let's take a look at some of the pros and cons here of Dynamo and talk a little bit about Evolve. All right, so this is going to be Dynamo and Evolve. So if you're like me, when I first learned about Dynamo, you might be thinking, can I use Dynamo for everything? Yes, you probably can. However, there's some questions that we probably want to ask ourselves and that we want to make sure that we have an answer to before we start down that road. So the first thing is, does somebody at my company know Dynamo? Well, if nobody knows Dynamo, they're going to have to learn Dynamo. So how long does it take to learn Dynamo? It's going to depend on how quickly you pick things up. You can start being pretty useful in Dynamo within 2 or 3 weeks. I would say to master Dynamo probably takes at least a year. So it's there's a lot that you can do and there's a lot to learn. How long does it take to create and test a Dynamo script? I've written scripts that have taken me a month to create for some of the more advanced ones that I've done. And then testing them takes longer, and it's also very difficult to fully test a script that you'll be using across multiple projects. Do my Dynamo scripts work in each version year of Revit? This is an important thing to take into consideration because Dynamo gets updated with every year of Revit, and many times the nodes that you're using, if you're using those custom nodes, will be incompatible in the new year of Revit unless that person who is creating that package of nodes updated it for that year. So there can be a little bit of friction there. Will my Dynamo script work on the next project? What Dynamo really excels at is custom, like kind of targeted problem solving. And so sometimes a script you'll spend some time on, it'll save you time on that project, but is it repeatable, right? Ultimately, we would like to have repeatable scripts that work on every project. This next one is a really important one to take into consideration. What happens if my Dynamo expert leaves? So if there's only one person at your company that knows Dynamo and they leave, who's going to maintain those scripts? Who's going to fix it if something changes in Revit, or if you have a new project where that script doesn't work anymore? So it's good. It's really important to have an answer to that question. And then the last one here, this kind of brings us into Evolve a little bit. Is there already a software solution that does what I need? There are a ton of plugins out there. We have ours, so we have Evolve Electrical and Mechanical. There are also tons of other companies that make really great add-ons for Revit. And typically those add-ins, like ours, are solving kind of the most common problems, right? So, we've got things that solve a lot of the industry problems. So, would it be worth it to recreate something like that? That's a question that you can answer yourself. All right, so let's talk a little bit about Evolve. So what is Evolve for Revit? So if anyone here is not familiar with what Evolve is, we're a company. We make an add-in for Revit or add-ins, and then we also have cloud products to facilitate the movement of information throughout the rest of your operations into your shop and field. The two today that we'll focus on, though, is Evolve Mechanical and Evolve Electrical. So before I came to Evolve, my company used Dynamo a lot. I worked a lot in Dynamo, and we had scripts that did maybe 5% of this. Ultimately, we ended up getting Evolve, and then eventually I came to work here, and that's how I wound up here talking to you all today. So we've got a lot of features that are focused on industry problems that you're working on creating your MEP models. So what is it exactly? Revit. We've got a plugin for electrical and mechanical. The goal of everything is really to increase efficiency for modeling, detailing, and managing your data in your model. Some of the most common solutions or most popular solutions that we have, spooling, hangers, conduit bends, reports, and much, much more, as you can see from the ribbons up top. Expansive. So there's been a lot of time put into these plugins. They've been developed for over 5 or 6 years now at this point, and so we've got around 70 features plus. We also have a content pack. So family creation is another kind of specialized skill, but we do ship with a very extensive content pack for electrical and a different one for mechanical. All right. So you may find yourself asking, should I use Dynamo or should I buy a plugin to solve my problem? So maybe it's Evolve, maybe it's something else. But the answer is do both. Learn Dynamo, but also look for software that does what you need it to do, right? Because you don't have to go and create it. So what Dynamo is really, really good at is custom targeted problem solving. So with a lot of projects, a lot of workflows, there's a lot of business logic involved. So we're all kind of doing the same thing, but we all have our own specific ways of doing it. And so sometimes the way you do things, plugin or off-the-shelf software may not be quite compatible with the way you do things. And so you can either change the way you do things, or you might look to Dynamo to help you solve one of the problems in your workflow. So that's what Dynamo is really best at. Also, being able to do it on the fly, right? So when you have a problem, you can just start working on it immediately and hopefully get it solved in time for lunch. Also, there's a very low barrier to entry. So, coming here and listening to me talk for about an hour, maybe spending an hour or two watching YouTube videos, and starting to work in Dynamo, you're pretty much ready to go. Now, your first script might take a couple weeks to really get working, but it is a very low barrier to entry. You don't have to spend any money, really just time and willpower. All right, so next up, Evolve. So kind of what we offer is built-in solutions for the MEP industry. You're looking at enterprise level software and support, tens of thousands of hours of development and testing. So, sometimes when people are being funny, they'll be like, oh, why wouldn't I just create Dynamo scripts to do all of this? It's like, well, you could, but it's going to take you a very, very long time. So we've invested a lot of time, and we're very proud of what we've created. Training options. So we offer training to kind of get you off the ground and be successful. Designed by industry experts. So I am one of the people that work on designing the product. My background is in electrical. I worked in the field. I worked in a VDC department, detailing, modeling, doing sheets, eventually was the VDC manager until I came here to Evolve. Highly customizable features. So you'll notice if you ever get a demo or take a closer look at our product, some of the features are kind of straightforward, but then there's also a lot of options for customization and some more advanced features to help you get the most out of your model. And then we also have new features and enhancements with each release. So we're continually reinvesting and improving our product. So that's it about Dynamo and Evolve. At this point, we'll open it up to Q&A. And I think we've already got a few questions. So I'm just going to run through those real quick. All right, so the first one here from Brad says, I'm attempting to support the increased use of Dynamo in our company. What are best practices for maintaining package libraries? Do I need to keep separate libraries for each model year and separate scripts for nodes not available for each year? Build off the oldest year. Best practice for that. What I would say, if you're going to maintain packages, yes, I would probably manage packages by the year. If you're talking about scaling, typically you'll want to use older nodes that work in newer years of Revit. You'll run into some where you have to change them. So sometimes you'll have the same script for multiple years. So when I kind of ran into this issue, I would add a suffix of like R21 or R20 because sometimes I would have to change the script because a certain node or package did not work for that year. If you're really talking about scaling, you have a couple options. You can either start to write your own custom nodes, and you can build those from nodes or from Python, or a customer that I ran into recently, they had actually hired a developer to convert all of their scripts into Python. So their script would end up being just a Python block. That's one way to go about it as well. Then you don't have any dependencies on packages. However, at that point, you've now hired a developer to do that. All right, the next one here, are code blocks written with Python? You can write code blocks with Python. However, some code blocks are just created from other blocks. So you can create a custom block and you can essentially put a script into a block and have it be its own block. However, the more advanced method is to write them in C#. So you can create nodes kind of the same way you would create plugins. And in Revit, that's done with C#. All right, next question here from Ty. Instead of placing a point, if you were to want it to execute a command like split element, would that node get swapped out, but pretty much be the same process? Yes and no. You would swap out a lot of nodes, and then you would split it. You would have to feed in where you want to split it. But it would be possible, and the script would look similar. It would be a pretty short script. All right, another question here from Ty. So can you explain what the difference is between a list and a Boolean? Yep, so a list you can think of as a container. A list contains objects. And then a Boolean is an object type or a data type. So a list containing objects or a container that contains objects, those objects have a data type or an object type. Boolean is an example of one of those object types. So hopefully that answers that. All right, next one here. Can you use Dynamo to create custom ribbons or toolbars? No, you cannot. They will always be executed. Well, there is a caveat to this, but generally speaking, they will always be executed from either the Dynamo player or from the Dynamo environment. Now, the caveat that I mentioned, there are plugins, or there's at least one that I have in mind, that it's a plugin, and what it gives you is it gives you 10 buttons. And you can take those buttons and you can bind a Dynamo script from it. And when you press that button, it will run the Dynamo script for you. And so one of the advantages of that is you can add a shortcut to that, and so you can start to eke out a little bit more efficiency, or it's a little bit more user friendly as well. If you're kind of trying to scale your Dynamo usage and introduce it easily to new hires. Will today's recording be available to those who have attended? Yes, Joel, it will be available. I believe Marina will be sending that link out. All right, question here from Peter. Does Dynamo have a test sandbox environment? Yes, it does. We didn't look at it. There is a standalone Dynamo sandbox that you can launch that's outside of Revit. You'll have to, your inputs won't be elements in that case. They'll be different things, but yes, you can. And if you type that exact question into Google, that will lead you to how you can do that if you'd like to do that. All right, next up here, will Dynamo and Evolve be useful for fire protection designs? Maybe. You won't really know until you go and you start building. So kind of whatever issues you run into doing fire protection design, things that, really repetitive, anything that you can essentially like create a set of steps for in your head, like first do this, then do that. You can create a Dynamo script for it. Does Dynamo work with ITMs? Yes, Peter, Dynamo will work with ITMs. There may or may not be a set of custom nodes or packages to work with ITMs. You can access them through the Revit API, which you would use Python for. So those working with ITMs, depending on what you want to do with it, it's going to be a little bit more complicated. But yes, ITMs work with Dynamo. All right, from Jacob here. Does Evolve take requests for use cases of Dynamo scripts that might not be developed yet? So no, we do not do any custom development of Dynamo scripts, unfortunately, but we do take requests for features in our products. So whether you're a customer or not, if you've got an idea for a feature that you'd like us to add, maybe if we added it, you'd consider buying. But if anybody has any ideas, we're always open to feedback. All right, what are some alternatives to Dynamo Player for deployment? Really, it's either going to be Dynamo Player or another plugin that actually runs the Dynamo script for you. So there's really not too many options there. Usually it's just from the player. All right, question here from Chris. Is there an option or package available to incorporate AI GPT-4 for design development and or clash detection and avoidance? Not that I'm aware of. However, it's entirely possible depending on what you're using GPT for. You can connect to APIs from Dynamo, so you can use Dynamo to connect to the internet. You could send an API request to the API for ChatGPT or any of the other AI models, and the sky's the limit. Can you run Dynamo on a schedule? Yes, you absolutely can. You can use Dynamo to create schedules. You can use Dynamo to get the information that is in a schedule and then export that or otherwise manipulate that information. Great question. Question here from Bo. This is a little off topic, but is there a way to use a PyRevit button to activate a Dynamo tool? I don't know the answer to that question, to be honest with you. I know it's possible because there's an add-in to do it. That's done with C#. I don't know if you can do it with PyRevit. All right, question here from Daniel. Is there a Dynamo script that can generate generative design for conduit runs? It might exist. If anybody's made it, they're probably not going to be posting that one on the forums. I'm not aware of anyone. You can do I believe you can. I haven't used it, but I believe you can do generative design inside of Dynamo. One thing I will note about that, one of our kind of skunk works projects that'll be coming into the product here pretty shortly is going to be conduit auto routing. So look out for an update on that in the upcoming releases. All right, last question here from Ty. I see a lot of Evolve tools use PowerShell script. Is that a thing that would also be used within Dynamo? No, not really. Typically what you'll use in Dynamo is design script or Python. And then if you're creating your own custom nodes, you might use C#. All right. So I believe that is all the questions, and we're about at time. So thank you everybody for coming. I'm going to turn it back over to Marina to wrap it up here for us.
Great. Thanks so much, Jason. And thank you to all of our attendees and registrants out there. We hope that you found this information valuable. Please make sure to follow Evolve on social media to make sure you're not missing any of our demos and keeping up with the upcoming webinars. As a reminder, this webinar has been recorded. We will send out the recording in an email to all registrants. Thank you again, everyone, and have a nice day.